Hello everybody, this is Dr. G. In this video, we are going to go over 2021 free response question number 3. So this is the area and volume problem. So the company designed spinning toys using this function, where C is a positive number. And the figure for this function is shown here. Each spinning toy in the shape of the solid generated when such a region is revolved about x-axis. Both x and y are in inches. So let's have a look at part A. So find the area of the region in the first quadrant bounded by the x-axis and the graph when c equals 6. So we are looking for the area here. In order to find the area, we have to decide in which direction we are going to integrate. So if you look at this problem, it's easier if we integrate along the x direction from origin to this point A. So first, start from 0. We need to find the coordinate of point A. So we set y equals 0. So in this case, y equals 6x square root of 4 minus x squared. We set this equals 0. So 4 minus x squared equals 0. Give us x equals plus minus 2. However, x has to be positive, so we'll only keep x equals 2. Now we find the boundaries. The area will be given integration from 0 to 2. We plug this function in. Just need to integrate this one. So the best way to integrate this one is using u substitution. So we define u equals 4 minus x squared. So du will be negative 2x dx. So if u equals 4 minus x squared, so the boundary for u will be when x equals 0, that's 4. When x equals 2, that's 0. So square root of 4 minus x squared becomes square root of u, and x dx is negative 1/2 du. So this will become integration 4 to 0, negative 3 square root of u du. So we are going to move this constant out because it's 0 to 4. We're going to switch from 4 to 0 to 0 to 4. Now we just need to integrate this one. So this gives us 3 u to the 1/2. So it's 2 over 3 u to the 3 over 2. Now we just plug everything in. So it's 2 times 4 to the 3 over 2 minus 0. You can leave your answer like this. You'll get full credit. So this is part A. Let's look at part B. It is known that y equals this and dy over dx. So this is y prime is given, so you don't have to take the derivative. For a particular spinning toy, the radius of the largest cross-sectional circular slice is 1.2 inches. Because we are revolving about the x-axis, so the largest radius here is 1.2. So this basically is given the maximum value of y equals 1.2. So we are looking for what's the c value. So in order to find the maximum value of y, we need to take the derivative of y, and the derivative is already given. We set y prime equals 0. So the denominator cannot be 0, so the only term can be 0 is the numerator. So we solve for x equals square root of 2. This is the only critical point. And at x equals 0 and x equals 2, the y value equals 0. So this will give us the maximum value. So we plug x equals square root of 2 into function y. C times square root of 2 times 4 minus 2. Plus c times square root of 2 times square root of 2. This should be the maximum value, 1.2. So c equals 1.2 over 2 equals 0.6. So let's look at part C. For another spinning toy, the volume is 2 pi cubic inches. What's the value of C? So this is revolving about the x-axis, and we can see the cross-section is a circle. So the volume equals integration from 0 to 2 base area times dx. Base area in this case is pi r squared, and r is exactly our y value. So we plug our y value in, cx square root of 4 minus x squared dx. Don't forget square. So this equals 2 pi. Now we can cancel this pi. So integration 0 to 2 c squared x squared times 4 minus x squared dx equals 2. So this is the constant. We can move c squared out. 0 to 2. We just need to take the antiderivative. So it's x cubed minus x to the 5th over 5. 1 from 0 to 2. We plug 2 and 0 in. We have 4 times 8 over 3 minus 2 to the 5th power, which is 32 over 5. So c squared equals 2 divided by 32 over 3 minus 32 over 5. So c equals square root of this value. You don't have to simplify it. If you want to simplify it, the answer will be square root of 15 over 32.